Today we are diving into small language model, to be specific, Meta's LLaMA model. Meta have made their language model open source to be used for industrial use as well. This is the third video of our series on language model. If you have not checked out previous two videos, how this language model work from a very fine-grained perspective. We also explored how these models are trained using pure PyTorch with a very simple example. But today we are taking a big leap from a small language model to a industry grade large language model. So if you go to Hugging Face and there you go to the home page of Meta LLaMA, you can see all the types of model they have released throughout. It started from LLaMA model, then LLaMA 2, LLaMA 3, and right now the current version is LLaMA 3.2. In LLaMA 3.2 also they have various versions going from 70 billion parameter model to a tiny 1 billion parameter model as well. So here in this video we are going to particularly use this one, LLaMA 3.2 1 billion parameter instruct fine-tuned model. When we say instruct fine-tuned, that means it is trained to respond to the user's query. The best part is this small model, you can run it on a smaller GPU with only 4 GB of RAM, or if you do not have a GPU, you can totally take access of Google Colab. First, we will need to download this model from Google Colab. But as you can see, this is a gated model, which means you need to request access, just sign up, wait for approval and login. Once you are in, you can grab the model. Now let's jump back to the Jupyter notebook and see how this part is implemented. We'll import from the transformer. If you do not have the transformer library, you need to install it. You can just write pip install transformer to install this in your environment. From there you import auto model for causal language model and the tokenizer. So first we'll specify the model name that we saw in the previous case, which is LLaMA 3.2 version having 1 billion parameter and which is instruct fine-tuned. So first we'll initialize our model from auto causal language model dot from pre-trained. We'll specify the name of the model we want to import and the precision. So this entire LLaMA model is trained with floating point 16. So we use that particular precision. This is less than the default setting, which is floating point 32. So you need to use less VRAM. That's the case. Use shape tensors. I'm not going deep into right now, but you can think of it like a checkpoint, a different version of PyTorch tensors. Then there is a device map, that which device you want to load this model to. Because I have a GPU, I choose that device. Then comes the part of tokenizer. In the tokenizer also I initialize by giving the name of the model. The tokenizer converts the text into numbers that the model understands. But different model have different tokenizers with different settings. They support different number of vocabulary size, different languages. Now that we have loaded our both model and the tokenizer, we can get some inference out of it. Because we want to use it as a chatbot, let's first construct our input. For example, here our input will look something like this. The first part, first you have to specify, it's basically a dictionary where you specify the role of the system, then what the content of the system. Here I specify you are a helpful chatbot. This part is optional. You give it or not, it's not very important. But next part is pretty important, that the user and the query of the user. Here I specify who is Mohandas. I just want to know whether it understands. I just want to see what is going to be the response of this chatbot. This part is optional, okay? But I cannot just pass this text to my chatbot model. I need to do some pre-processing. For that comes this part, tokenizer.apply chat template. What it does, it basically converts this whole thing into texts like this. So from this part, after you do the beginning of text, beginning of text, start header ID, then system. So it basically adds some special tokens before and after to let the model know that this system is not a part of the query, it's the special token. It also adds some other part like cutting knowledge state. That means this model has all the data of the internet until December 2023 and gives the date of today as well. This part, this entire part is converted into something like this, from starting from here up to here. All right, and then there is another part we specify here is add generation prompt. That means it gives, because in the end the llama model is nothing but a glorified autocomplete. So when you write add generation prompt, it specifies that okay, now you behave as an assistant. This part it adds to it. Start header ID assistant, and after that this is the autocomplete. Like the llama model goes on autocompleting whatever it until the end of sentence is reached. Then the generation part is stopped. Okay, so yeah, this part basically converts it into text, and then I apply the tokenizer to convert the text into numbers, which are my inputs in this case. I pass these inputs to the model.generate function, which does the generation. And if you in the previous couple of my videos, I already specified that the generation doesn't happen in one go. It is an iterative process, and it only predicts one word at one time. Then that word is again appended to the original sequence of token, and then the next word is predicted. And here I specify how many number of tokens I want to generate. So here I specify that 100 times. That means run the loop 100 times internally. And whatever is my output, then I use my tokenizer to decode that back to the actual text space. So here we see Mohan Das is a popular Indian television actor, comedian, and model. He's best known for his role in several Indian television shows and films. So that's what the model knows internally in his internal training data. But how does this model generate? We want to know what is going on behind this generate method, which I have already specified in my previous couple of videos. Now I created a simple for loop to show the generation process. The input ID remains the same, which is as the previous one, this particular thing. I pass the entire input to the model, get the output, and in the output I just care about the last generated token. So this logits, and I go to the last generated token. This part, the logits, give me probability over the entire vocabulary, and from the entire vocabulary of the words I choose the word that has the maximum probability. And it is also known as greedy decoding. There are other decoding method also, such as sampling, where there is some randomness in the generation process. We'll see that just after. Then I append this new token to my original token sequence, and I do this for, let's say, because I specify a maximum generation token 10, I generate it 10 times. And finally I decode it using the tokenizer. So here you see, if we run this, see, this is the generated part. Mohan Das is an Indian television actor model. But now I want to see that what is the probability of different words at different time. So for that I did something like this. So you see, at the first step the highest probability is on M, the token M, then is on OHAN, then the highest probability is on dash, then ish. And in this particular generation method I take the token with the highest probability, but it's not always have to be same. At when you write here do sample equal to true, for example in this one, do sample equal to true, it takes, I think, top 10 most probable top 10 tokens with highest probability and randomly samples one from them. So this introduce stochasticity into the generation process. That means in ChatGPT, if you have seen, if you rerun a prompt or regenerate with the prompt, you get probably a different answer than your previous one. So this is introduced by this particular method. All the codes whatever we saw today are available in my GitHub. You can go there and run along with this video to get a better understanding. If you have any doubt, don't hesitate to ping your comment down in the video. And yeah, in the next video we'll try to fine-tune this llama model for just one sentence, so we know that how the fine-tuning process works for a llama model. And in the future videos I want to show how the retrieval augmented generation works with a simple llama model like this, how we can do agentic framework with a simple llama model. Yeah, if you find those topics to be of interest, definitely subscribe to the channel.